In this case study, we've got exactly the same issue we've seen in our prior case studies. This PC cannot get to this host on the internet. And again, we want to work our strategy. As we follow the path, we see how far we can get towards the destination before we can get no further. Let's begin by making sure we're interpreting the issue correctly. I'm interpreting the issue as I'm going to be unable to ping 203.0.113.1, and that is confirmed. I am unable to reach that host on the internet. And on the real exam, you might give an ipconfig command at this time in a PC simulator to make sure that you have an IP address. Maybe it's statically assigned. Maybe it should have been learned from a DHCP server. And if you don't have that IP address, maybe it's one of those self-assigned addresses, then you need to start troubleshooting why do you not have an IP address. You might need to work your way from the PC towards whatever device is acting as the DHCP server. And also in that ipconfig output, we can see what our default gateway is. We can make sure it matches up with the topology we're given. Here, if I do a show IP route, we'll see that this PC, which is actually a Cisco Catalyst switch, it's got a default gateway of 10.1.1.1, and a show IP interface brief shows my IP address of 10.1.1.100. That does match our topology. So now we're ready to start following the path. Can I get to my default gateway? Can I ping 10.1.1.1? Yes, I can. And our strategy that we've been emphasizing is we want to ping the ingress and the egress interface of every router or multi-layer switch hop from the source to the destination, at least as far as we can get on our path to that destination. I am able to ping the interface going into DSW1. That's my default gateway. Can I ping the egress interface on DSW1? That has an IP address of 192.168.1.2. That is successful. What about the ingress interface on R4? That is successful as well. Let's now try pinging the egress interface on R4. That's 172.16.1.2. That works. What about the ingress interface on R3? We can reach that. What about the egress interface on R3? That is 10.2.2.2. That works. What about the ingress interface on R2? That is successful. What about the egress interface on R2? That also is successful. What about the ingress interface on R1? And we're able to get all the way to router R1. I wonder, can I reach the egress interface on R1? Can I ping 192.0.2.2? Yes, I can. Can I ping my ISP with an IP address of 192.0.2.1? No, I cannot. I'm not able to reach the ISP. Well, in the real world, we're typically not allowed to go look at the configuration of the ISP router. We need to configure routers at our site, our enterprise routers. And in this case, I go all the way to the edge of the enterprise network before my communications starts to break down. That means I'm going to go to router R1 and focus my troubleshooting efforts there. On router R1, let's see if we know a route to reach this host on the internet. I'll do a show IP route. And not only do I not see a route that would get me to 203.0.113.1, I don't see a route that has been learned via BGP. I don't see any route that has the B code in front of it. I've learned routes via OSPF, but not via BGP. This is suggesting to me that maybe I should start troubleshooting BGP. Do I have a BGP neighborship with my ISP router? And if not, let's recall some of those things that have to match up in order to have a BGP neighborship. Let's do a show IP BGP summary command, and this will show us our configured neighbors. Here's my configured neighbor IP address, and this is not looking good. We see that its state is idle. We have not received any prefixes. We do not have a neighborship with our ISP router. We see the autonomous system in which the ISP router is supposed to belong, and we see the IP address that we've configured for the ISP router. Now, what I want you to do is take a look at this output on screen and compare that with the topology that you see on screen and see if you can determine, before we look at any configuration, see if you can determine our underlying issue. Did you notice as you were looking at the topology that the neighbor's IP address is actually 192.0.2.1? 2.1, not 1.2. It looks like those numbers have been transposed. Let's correct that. Let's take a look at our router configuration. I'll do a show run pipe to section router, and we see under router BGP 65001, I've incorrectly specified my neighbor's IP address. That's something that's very easy to overlook. I just had a couple of numbers that were transposed. Something else that's easy to overlook is I might have had a couple of numbers transposed here in the remote autonomous system number. In this case, that looks correct, but it's something to watch out for in the real world and on the exam. Let's fix this incorrect neighbor statement. Let's go into router configuration mode for BGP autonomous system 65001. And I'm going to copy-paste this to make it easy. Let's do a copy, and I'll say no to negate that command. I'll paste it in. Let's paste it in again and correct the incorrect IP address. Let's make it 2.1 instead of 1.2. And here in a moment, we should see some confirmation on screen that we have an adjacency change, telling us that we formed a neighborship with our ISP router. And there it is. We've got a BGP adjacency change. We're now a neighbor with 192.0.2.1. We can confirm that by reissuing the show IP BGP summary command. Before, remember, the state was idle. We had not received any prefixes. Now we have received 2 prefixes. Excellent. Let's go back to PC1 and see if we've resolved our reachability issue. Let's once again try to ping 203.0.113.1. Success. We have resolved our issue, and in this case, the issue was a misconfiguration of our BGP neighbor. Very easy to miss as we're looking at configurations under the time pressures of the real world or the exam. We just had a couple of numbers that were transposed. Keep a watch out for things like that on the exam and in the real world.